How's it going, everyone? Welcome to another video on front-end system design. So Elvira Gonzalez here. We're going to look at how we're going to create this virtualization list with plain old JavaScript and the DOM operations. But before that, we're gonna make a quick recap of how do we get here, and then we can finally get our hands dirty. So the idea of this is because in this case I want to dedicate my time to be a UI specialist, and if you want to do that, you need to know the fundamentals of how you can now build front-end applications, or the fundamental of system design, because at the end of the day this is something that you want to provide. You want to not only build but also to maintain. So this is two sides of the same coin, right? Building and maintenance. So in this case, from this side of the coin, we're looking at how can we build this by understanding is a fundamental of front-end design system that allows to build these web large-scale applications. And for that, well, luckily for us, that Yves Ray actually is a software engineer that now works at he previously worked at JetBrains, and now he's currently at Meta. He described, at least in this particular course, of how can we do that, right? And what are the fundamental things that we need to do, the core fundamentals, and here we are going to move on to this specific topic, the virtualization, as a way to see how can we do that, and we're going to briefly describe is each one of those topics. So first is to understand that applications in the context of computers and the software is made of three parts. So this is the anatomy. So you have now the backend, the API, and the frontend. Because in our case we want to focus on the frontend, right? So the frontend here is made of several components. Or in other words, we have been responsible for several things, right? So first is how we're going to communicate to our API, which is API communications. The other is, once we do that, how we're going to now store that information and handle it, data management layer, as well as how can we deal with the user pattern or the user interface pattern, specifically the more common use cases. So for example, like analytics, so way to check how many times for how many seconds a user is actually looking at this particular piece of content on your website. How can we now update this content as the user is scrolling, aka virtualizations, adding elements. Also, how can we provide tools that allows to take notes, text-rich editors. How can we do that? Or drawing tools, right? So for example, for signatures, okay? And when it comes to actually show data in a responsive way, so whether it's on the tablet, the laptop, tablet, or mobile phones, how can we actually work and show not only relevant data, but also in a way that is usable? And this is just to mention some of the common use case that we as user UI specialists, we are going to be asked for. All right. So it's analytics. How can we load recurring components here as a user see fit? How can we provide this interactivity with taking notes, text-rich editors, or drawing, or showing is data visualizations, whether it is bar charts or line graph, area charts, heat maps, geo maps, and you name it, right? And how can we show that in a responsive way? So whatever the user is now, whatever end user whatever end device the user actually is using, how can we actually provide the best user experience for that particular case? And I think this is something that is quite compelling, because this is one of the role of these UI specialists, not only build but also to maintain. So because of that, we also have a responsibility that once we load all of those assets, okay, that allows to show something to the user, how can we manage that in a way that is quickly, in a way that the user experience is not impact for that, which is asset management. HTML, CSS, and JavaScript fonts, image, video, you name it. So because of these particular areas, first we need to understand is the fundamental of the platform that we're going to build our app. And that is the core fundamentals. The TLDR of this is that here we look at how now the browser treat HTML elements by putting a box around each one of those elements. When it comes to show that, understand the box model and the box anatomy, which is made of the content padding, border, and margin. And then anytime you want to, for example, or to look at the properties of these boxes, you have it per size and per type, and that is now, for example, block types and inline types. Each one of them has a set of rules of how this element is going to behave, which is known as the formatting context. So this formatting context, which is something that is useful, and is not only because it provides isolation to these elements. Hey, other outer elements won't affect this set of elements, as well as it is scalable, because now you can not only use a set of rules that these elements will behave when it comes to display on the screen. So for example, block from left to right, in the case of block is from top to bottom, and in the case of inline element is from left to right. But also it can be scalable. You can define some other formatting context like flex or grid. So how enabling you is the ability to create a more complex web interface. And it is of course predictable because each one of them has a set of rules for that. So then we look at how the browser position elements here, that is using now a stacking context, how you can use that as a way to now certain layers of your elements to be optimized. So by isolating this set of elements here, you optimize that using some of these CSS class transformations, and as a way to create this stacking context you use is now the position, relative or absolute, and creating this stacking context is something that you want to do, especially if you're handling a lot of elements here, or you want to show relevant data to the user, or you want to use the CPU for that. So why this is important, especially if you want to provide more riches and interactions to the end users, it is important to know then how the browser actually works behind the scenes. This is known as a critical rendering path. We're not going to dive, I'm not going to dive deep too much in this concept, but the TLDR is that this is the way how now the browser transforms HTML, CSS, and JavaScript and turn them into pixels on the screen. So because of this is when the DOM and the CSS objects created, and then you have now the render tree, which is the combination of these two models, two data structures into one, then the browser needs to know how to compute, how to calculate is the position and the geometry of each one of those elements. So once he knows that, all right, by running is the reflow phase, where here is when it's going to now use CPU or GPU. So when you change the layout, the geometry, or the position of these elements, you actually are triggering, you're telling the browser to triggering is this CPU operations. So instead of doing that, instead of actually change the layout for that via JavaScript, manipulating this DOM object via CSS, you can now skip that layer, or you can now skip that calculations by using it as a CSS, for example, transform, right? So this, instead of actually triggering that layout phase, it will now is triggering is the paint and the composite, right? So it, in other words, is going to now talk to the GPU and say, hey, I want you to now is calculate is this. So the thing here of this paint and composite and how that works, especially here of the when we want to create these layers of specific elements, we want to apply a lot of animation from that. This is now the way of how you can actually not only create this, but when it comes to build user interface like cards, okay, you want now is to do that in a way that now GPU is getting triggered. So because of that, we look at how now is how you can actually talk to the graphic layer, how you can talk to the render layer, especially when you when the browser pass through the composite layer. Once he know in memory all of these paints that I need to do, in the composite say, okay, now how all of these different paints actually made the final web page. So because of that, and if we want to create user interface, well, we look at a quick refresh of the DOM, okay? And what is a DOM? Which is a set of methods that allow you to talk, manipulate, interact with the DOM model. What are the global objects that you can use, as well as what is the DOM structure here, which is the node as the abstract class that act as a blueprint for another classes like text node or elements, and then therefore in elements you have HTML elements, math elements, SVG or any XML elements. And also from node it extend the HTML document that has now the window objects. So when it comes to actually now querying elements, we have so far 4 methods. We have the get element by ID, and get element by class name, get element by tag name, and query selector and query selector all. I actually described 5 here. The TLDR of that, all right, or the good practice and the performance issue is that get element by ID is the fastest one, but it has become an anti-pattern because you need to have a name convention with a discipline to use these IDs, right? So most of the time we use this ID as a way to identify what is the entry point where we want to get these elements and all of the sub elements from there, right? So this is one of the optimization. The other is so the read cost and the time cost is actually all one, because you're actually it's pretty much like reading elements on a hash map, okay? And the other is the get element by class name and tag name. The TLDR of this is that because now it exposed an HTML collection, which is a live collection of the DOM, it doesn't have any overheat on memory. But you have to be careful anytime you want to get that live collections and iterate over that, because the read cost of this is or the time complexity is ON, even though that is ON with an asterisk, because it is using the DFS algorithm in this tree data structure as a way to search elements in there, the deep breath first in order. So going to the most right elements, it goes through the most right elements, righteous elements, and then to the left, and then it goes through the most leftist elements, and then to the right, and then to the node, and so on and so forth. All right. And many times you now query that element, okay, or you get that element, subsequent queries to that, now it is stored that on a hash map. It has this performance optimizations as a way to next time you get that. The only trade-off is that this HTML collection is, because it's live collections, it can introduce now some errors that, for example, you are assuming that some elements are in there when other functionality actually change that, and that's caused that have this kind of inconsistency, especially when you're going to run functionality. So that's why query selector in query selector all, with query selector returns you now an element, and query selector all return is a node list. They return you is a copy of that, and this strategy has been a very good approach, because you are not modifying that the read codes of the query selector, and query selector, especially query selector, is O1 or ON. If this is the first time, it actually need to take that it actually need to traverse that using the DFS, but if this is the how do you put it? Yeah, but if this is now the so if this is the first time that you're using query selector, query selector, by using the CSS selector, the thing is that it takes time. You're gonna go through, you're gonna use the DFS, so you're gonna take time until you find it. So in the worst case scenario, the time complexity is ON. So far so good, because then subsequent query do the same, subsequent equal queries. Now, thanks that the browser has these optimizations in place, you can get that quickly, O1, in a constant time. So the TLDR of this is, even though the query selector and query selector all provide you now a copy of that, now you have a burden on memory here. So again, it's kind of a trade-off. The good practice when you're using is that for query selector, it's like say, hey, you know what? Let's go to define a simple selector. So simplify the selector, as well as when you're using get element by ID. All right, set them on the starting point that you're going to work on that sub-tree elements. So pick the right starting point for that. And then we look at the method of adding and removing. The TLDR is that using is just use the append child for that, and the remove elements. Also, we look at how can we starting to create a simple user interface. So for example, with a simple car, and how by using is the template HTML elements, which now tells the browser, hey, I don't want you to render the elements. In fact, I want you to hold that, and then we can later on access through that at runtime via JavaScript. So the reason of this is we can now do some operations with these elements on memory. In this case, populate, get that element and get that element, clone that, and populate that car with the proper data, and then we append that. We do the append at the last, because now this is when we're triggering is the reflow. We are adding elements to this, so the browser needs to actually calculate that. So we are not doing is at the initial load and then access to all of those elements and change that element on the fly. The process of assembly thing here is not doing that when the page is loaded. All right, I mean, the process of assembly is not only put that template and then operate on that. In fact, it's to create that template with the necessary data, and then we apply that. And I think this particular paradigm here is something that it comes from the functional programming as well, which is this pure functions and immutability. So in any case, we also look at the most complex web API, or the most common use case as a UI specialist when it comes to actually build these particular patterns. So as I mentioned before, so for example, if you need to have a virtualization or adding elements or on the fly, so lazy components, or for analytics or dynamic view elements, we have now a particular pattern to do that, the interception observer. If we want to, for example, now keep track state change on the DOM, useful for text-rich editors or drawing tools, now we're gonna use is the mutation observer. And today we're gonna focus is on the last pattern, which is the resize. So this actually now tracks element size here and say it tracks elements size. It tracks elements. In fact, this is not track element size. Well, yeah, because this is the box model. So okay. So it track element size. This is something good. For example, as I mentioned, for you want to show now. So for adaptive design, useful for architecture or for anything, that kind of thing. Adaptive design or charting tools, right, as well as drawing tools. So we look at now how can we use interception observer, how we use that in the past by using is now the callback queue only exclusively to detect at certain milliseconds how these two elements actually overlap using the element class property from the get bounding client element, so we can calculate is that when that position is intercepted. All right, that's quite interesting. All right, so if the rectangle bottom, if the rectangle top, they intersected. So for example, if the rectangle in A is greater than the rectangle on the top, okay, so this is actually calculating is, hey, if the element A and the element B is actually overlapping in this and not only on the top but also on the right and the left, all right, and also the same for the element here at the top. So this is quite interesting. This is very, very interesting. So we have to know this particular logic here in place as a way to calculate that, hey, is the bottom of these elements and the top of these elements uh, is the bottom of this element greater, because remember we're using is the position browser here, starting from the left here, from 0 0, it started from here. Is this rectangle here, the bottom of this rectangle is greater than the top of this rectangle, and if this rectangle is greater than the right, so it means that we right on x axis is greater than the box on the left side, it means that they are intersecting. The other thing is that if the red element in the top, okay, is greater, and I think that this logic can be quite confusing. It's not like that, but the thing here is that they actually need to calculate is the position of these elements using is the get bounding Klein rect property as a way to calculate is this overlapping. And not only that, any certain milliseconds you're gonna trigger so you're gonna pass that to the callback queue as a way to check if those elements are intersecting. So this is of course something that is drain the callback queue resource to only handle is the interception. But now right now we have is this particular queue to handle is the interception observer. So that's quite interesting because we can not only is observe if one element, but we can observe is several elements for that. We also look at how can we create that, what are the configurations, and what are the callback, and how can we most of the time use that. We also look at the mutation observer as a way to keep track is how these elements are changing, okay? And this is, hey, I want you to now look at this particular element, in this case this div, and all of the and all of the child components, and when the content in each one of those child, or in even itself, or the property of this element or the sub elements or the nodes actually change, I want you to now trigger this particular callback. So this configuration of the mutation observer is something that is quite you have to be careful of this and how you're going to do that. We also look at live coding as well to do that, as a way to generate all of these elements first. Once they intercepted, we create that, and then create on the fly all of these elements, in this case 10 elements here, and then per each one of those elements we are going to now is put the mutation observer as a way to say, hey, I want you to inspect this set of elements or observe this set of elements when they're changed, when the character data change, and we're going to replace that with something is here. So this is quite interesting because what we did here is this one, and this is something that applications like Notion and that kind of thing they are doing is behind the scenes. So this is something quite interesting, very interesting, very interesting. Very interesting, very interesting. So what we really get into this video is now the mutation, okay? It's not the mutation as well as the virtualization. So let's get into this. Let's get into this. The Resize Observer. So this is something beautiful as a way to recap how do we get here. Do that in the most fastest way possible, because you not only solidify some of your concept, but also looking at certain flaw that you're thinking that you have in your thinking, that you got in your thinking. and most of the time is those nuances that allow you to build that kind of thing. So right now I am confident to build this user interface with a framework, which is a good thing, okay, especially for working with WordPress and that kind of thing. It's like, okay, that's good, that's great, how you can optimize that kind of thing, as a way to work with plain JavaScript, plain old JavaScript, right? Good, good. Something that is useful, especially for Shopify applications. Okay, when there is a lot of things that you want, that you are actually loading, and how you can try to minimize as much as possible the assets there. Yeah, completely, man. So Resize Observer.
So for instance, if we resize the window, then we have two main methods. How can we do the changes on the web page? First is CSS media queries. It's used when we build adaptive design, or it's the resize event. When we track the
So when we need to track when the size of an element change, we have so far 2024 this way of doing this way of doing this, or we have this, we have this, so we have this. So you have now through the window, okay, you can check that through the window. So we have this window, we're now on the window. You have now is the resize event, which is not performance, and then you also have the CSS media query. This is from window, and the other is from the element. Right, element. Let me actually is put it. No. Okay. Definitely fuck. Elements and CSS container query. I'm not familiar with this. Exactly. This is from JavaScript. This is from CSS. Okay. And this is from CSS. Interesting. You have CSS container query. Okay. Allows to change the appearance of the UI based on a container size. I never used that. Best approach performance wise, however, to wait to run our own callback. And the resize observer, right, which is through GSS, through JavaScript. So to understand now the trade-off of each one of them, so you have now from window that you can use the resize event, but this is can fired too many times and you don't want to do that because anytime this is an event that is not bubbling. Even though that is not bubbling, you can trigger this element a lot. We of course have a performance penalty. You have a huge impact. You have a huge negative impact on the performance of your application. We also have the CSS media query, okay, but this is through CSS, and then from the element class, we have now the CSS container query, okay, and that allows to change the appearance of the UI based on the container size. And this is one of the best approach to run a callback, but this doesn't allow us to track the element, whereas the
Element
Resize
size.
Observer, yes.
Then there are two
CSS media query, CSS media queries, but this is through yeah, I'm quite familiar with this. This is a way to calculate that. To conditionally apply styles with the CSS media import at rule, test and monitor media state using the match media and event target at listener. Test and monitor testing media query program. Okay, testing media query programmatically. Okay. Okay. Yeah, this is the best approach for calling that, but not for tracking elements. Interesting.
other options. There is a Resize Observer that allows us to fire the callback, and there is a CSS container query that allows us to change the UI. So let's compare all of these methods from the performance-wise. So the CSS media query is performance-wise is the best way to do the adaptive layout cases when you don't need to actually execute any JS callback. But it has some limitation. We can fire any callback, and we also can track specific element. So for this specific reason, the CSS container query is implemented, so we can set up the container that we're and based on this container.
I think this is quite interesting because this is the way of how you can track elements, how you can now track the size of an element. Okay, so you have CSS media query, which is great. They're super fast. This is from CSS, but it doesn't allow you to now track elements or run any callback, right? This is default. This is when you don't need to do this kind of thing. Makes sense. The other is CSS container query, which is triggered by JavaScript. Okay, allow you to now run a callback. It's super fast, but it doesn't allow you to track elements for that. Then when you need to track elements, we uses the window object called resize events, but because this can be triggered a lot, right? If you're not careful, this of course has some performance penalties. And then you have now the Resize Observer. This is something that is this is something that the Resize Observer. This is something that now spec developers create this web API interface that report change to the dimension of the element's content or border box. Exactly. But after all, it's a way to keep track the change in the dimension. It's a way to keep track the element's size, content, or border. Content. Okay. So the observer, the Resize Observer is a way to track. Okay, track elements. Okay, so the Resize Observer is a way to track elements here. To track elements size. exactly. It's a way to track element element size, content. Yeah, it's a way to track. It's a way to track element content and border. Okay, element content and border. How the French does. Okay, element content and border, or the bounding box of an SVG element. That's quite interesting. The bounding box of an SVG element. The bounding box. That's powerful, because if you're able to manage the bounding box of this element of the SVG of an SVG element. Exactly. Attribute style map, attribute data set, class name, no owner style. That's quite interesting. Events, error load, inherit elements, node, event target. Relevant to page for SVG. This is editor draft. Exposes on the window global object. Interface SVG element that is come from elements. Same object read only attribute of SVG element, SVG element. And it includes global event handlers, document elements handler. Interesting. Of course, that's one of the reasons why this is used heavily on the elements node and event target. Holy F, bro. Don't you have a okay? Alright. SVG API. Scalable vector graphic. Okay, the bounding box. Element content and border. Okay. And the bounding box of an SVG element. The bounding box of an SVG element, whether it's the bounding box of an SVG element. Okay. That's quite interesting. Okay.
Your size, we can change the children list styles. So it's also why your application is potentially slow, goes from bottom to the top again. So this is called bubbling mechanism.
Yeah, this is one of the JavaScript, but the resize events does not actually trigger that. The resize event does not trigger that. The resize does not trigger that. But this is experimental. Interesting. But the resize from CSS, but no, the window. The Windows resize. say resize. No, resize event window is this. This event is not cancelable and does not bubble. So it means that this way of know when that event happens and bubbling up as a way to now, well, trigger all of those events that happen on, and trigger all of the callback of the same and trigger all of the callback of the same event. Not all events are bubbling, okay? For example, click is one of them. Resize does not bubble. All right. In some early browser, it was possible to register resize event handler on any HTML element, and it still is possible to set on resize and use that event listener to set a handler to that. But one of the trade-off of this is it get triggered. If you're not careful, it can get triggered a lot because this is now part of the window. However, resize events only are fired on the window objects, on the document on the window object, the visible part of this. So while resize event fires only when the windows, for the window node, you can resize notifications for other elements using the Resize Observer API. And this is how they run this. Window height. And I think this is, if you want to run this, inspect this, exactly. It get triggered is that resize the browser window to set the fire. Let me see, it's here. Exactly. But it's because it's getting triggered a lot, you know, from the window objects. It doesn't allow us to keep track the elements. That's one of the trade-off of this. Is like, yeah, we can now know when that happened, trigger this callback, but we don't know. We can't track that element. Okay, it is positioned for that. So this is great. All right. When main size window change, okay, so when size window change, you're going to trigger is this. But the thing here is that we are not able to track elements. So for example, we are only tracking is the window object, not the elements. And that's why the resize object makes sense. That makes sense. And that's why the resize observer kicks in and say, hey, now we have the ability to not only keep track when the size of the window object changes, but also when the element changes, when the content at the border of this element changes, or the bounding box of an SVG element. Oh, okay. I definitely want to see is now an example.
My recommendation would be to not to use resize event unless you really need this or you're supporting some legacy clients. So it's always better to rely on Resize Observer instead, because the Resize Observer was designed specifically for this case when you need to track resize of the different elements in a very fast way. So the Resize Observer on average around 10 times faster than the resize event. It also supports the callback, so we can fire the JS callback on certain element resize, and we can track multiple elements with that. So we can combine the CSS media queries with the Resize Observer to build our complex adaptive layout.
That's the subtle difference here, the nuance.
And before we jump to overview of Resize Observer, so the Resize Observer has the most simple API actually.
Okay.
So
that's interesting.
A Resize Observer constructor doesn't take any more arguments except the callback, and the callback has just and the callback itself has the resize entries. But let's first understand what are the properties that the observe method takes. So just one property, which is the box, and you can set up the box as a content box or the border box. So in case of the content box, will just track the size of this blue rectangle. So if you change the padding or the border, the observer will not be triggered. And if we use the border box, then we utilize both the border and the padding in the resize event calculations. And the Resize Observer entry has a slightly weird property set. So it has the border box size, content box size, and as you can see, it's an array of boxes. Why it's an array of boxes? Why it's just not a single box? And apparently, so the spec developers, so right now, you will always have a single element in this array. But the spec developers, they think that in the future, we will have HTML elements that may be not just a single box, but may contain multi-column layout in one single element. That's why we need to track multiple columns within a single element. And in the future, we're going to use this array of boxes. So but right now, you will always have just a single element because there are no such multi-column elements at the current spec. So also there is a target element that we are going to use, which gives us the element that triggers the Resize Observer. The callback is implemented similar way. It takes the entries, and we need to loop through the entries. And to access the width or the height properties, so we use the first element of the border box size. So as you can see, it's the so because we always know that it's just a single element, then we use the 0 index here. And here we have the inline size and the block size. So inline size corresponds to the width, and the block size corresponds to the height. And then we can set up the Resize Observer for multiple boxes and trigger the callback.
So that's quite interesting. And let's now get into an example, my friend. Shall we?
And again, it's exercise time. We are going to build a simple exercise where when you resize your rectangle, it becomes the circle when the rectangular size is less than 150 pixels. So here now we have 4 nice circles, and if we resize it back, it's again rectangle. And you need to check out the following branch for Resize Observer start. And we're going to create a Resize Observer and track all these 4 elements and fire the callback. So let's get back to the code now. So I'm opening the Resize Observer begin branch. And here we already have all the boxes set up. So I guess what we need to do is we need first so first, let's initiate the observer.
So the way to observe each one of those elements is that, okay, we're going to observe these elements here. So once we initialize this server, we want is to then, so when we initialize the observer, okay, it's like, hey, Paul, stay here. We're going to initialize the server. We're gonna get this entry points of our elements, and then query from this subset of them elements, query those elements, okay, and attach the observer to each one of them, right? And then when a certain event happens, or when a certain amount of pixel happens, I want you to now transform these elements into another one. You know, I want you to transform is the border radius as the property. Exactly. I want to transform is the border radius to property into another one. This is quite interesting. Okay, let's get into this. Oh, my French toast guy. Oh, hell yeah. All right. Yeah, let's get into this. So well, first things first, let's go to change to cursor here. What we're looking is this kind of thing. But this is now exactly enterprise UI development. Then you got the dispatch and D&D, components, e-client, advanced Redux, and enterprise, e-ticket. Really? Oh, there's something lovely from this. There's something lovely for this because I can change. Oh, I love it because I can change multiple projects here. Accident counter RT key. Nope. Find pair. No. Auth content. This is a ticket. A ticket on here. Interesting. No. Portfolio Next.js. Great, but no. That might be quite interesting as a way to create all of these elements on the fly. All right. No. E-ticket. Really? Did I close that? API. This is API design. This is colors, but this is for optimization, performance. No. Take care. Bye bye. Portfolio next. E-ticket. Source control. Accident counter. The complete intro to React as a way to look at that. Portfolio next, e-ticket, source control, code solution. Did I close that for real? No, I closed that. Okay. Well, no problem. No, I have the okay. I have that is on the live code. Yeah. Okay. Good. No problem. No problem. No problem. No problem at all. Please give me is the code sample. Oh, but I think we'll need to go to this. This is exercise time. All right. But the mutation to the, in this case, is the Resize Observer star. Okay. This is now the exercise. Exercise here. Exactly. Exercise. There you got it. Period. And the live code, which is something that we're gonna do here. Okay, Resize Observer begin. Yeah, but the idea here is that I know what we're going to do, right? I know the design of this. So, because the whole point of this is to build this applications where we are able to resize each one of those elements, and when a certain threshold or when a certain width happen, okay, we want us to now change the shape of these elements. But this is something powerful for drawing tools. Very, very powerful for drawing tools, because now you can have the ability to keep track of this and to resize these elements. Interesting. So we go now to put is some when we're hovering, okay, because when we're hovering into that,
if we resize back, it's again rectangle. And when the size is less than, the rectangular size is less than
exactly,
150
when most
pixels.
hover is this.
So
exactly. When most hover is here, we want us to now apply this. We want to change that. Interesting. I think cursor CSS, which is a property here that allows to do that, is that help us to the drag and drop. Exactly. Help crosshair not allow, zoom in, grab, and this is just to describe the most common that. Exactly, general, link status, cell text, alias, copy, move, drag and drop, resize, resizing a scroll. That's beautiful. That's beautiful. Oh my god, I never. Oh my god. What the hell is this? Oh my god. Oh my god. Oh, Jesus. Oh my god. All right. Some edge is to be moved. For example, the resize cursor is used to be set the movement start. Oh my god. Yeah. So this is a property that we're going to apply to all of it. Okay, let's get into this. And then I'm going to look at how we can do it. Okay. All right. I have an idea of what we have to do based on the previous pattern of how we have done this kind of things, right? Leave a page, bro. I want to create now a new fork here. That's silly, but actually it's something that you can play with. Okay. Are you gonna do that? Okay. Yep. Now it's running this virtual machine. That's right. So it's a mutation API. Let's go to create a new branch here, right? Create branch. Where here we're gonna say, hey, resize. Resize API. All right. So that now, unlike so it's because we already having the pattern here. We're already having the mindset here of what are the things that it needs to be done. Yeah. So this is not the Resize API. There you got it. Okay. Here we don't need any of that. No utils, no none of that shit. None of that's S. None of that S. Okay. The French toys. They delete permanently. Similar for this, delete permanently. We don't need any of that thing, right? It's only a single HTML. That's right. And the style here. That's right. That's the only thing that we need to. Card box. No, but exactly. We got everything here. Okay. No utils for this. Backspace. Oh, backspace. Interesting. Okay. Good. Now let's go to create the index HTML here, which is the index.html. This index.html will contain is now not only the necessary data here, like meta char sets. Is like, hey, this content will be used as this unique code format code. Okay, and this will be the title. This is the style we're gonna load here. Okay, this is the first child. There you got it. So if we save this and we rerun it, we got is this. Wait, what? Why this is working? What are you applying now the resize here? The proper resize. Oh, it allows you to resize that? Oh, crap. The resize here is a limited availability. Exactly, because if you don't put the resize here, for example this, alright, and then you reload that, you won't resize that. That's quite interesting. Limited availability. Safari, no. What? French toast? Resize does not apply to the following inline elements: block element for which the overflow property is set to visible or clip. So we use that is for flex elements. Yeah, flex element. Interesting. Very interesting. So not only that we oh my god. So not only that CSS, or in this case the browser, again, writing a browser is not something, it's not trivial as it may be. There are more than 31 million lines of code at least in Firefox. God damn. That's the amount of people on Venezuela or Yemen. I think Nigeria is as well. Jesus. Anyway, yes, we got this. Holy F. Alright. And now they provide us so the browser, when we put, oh my god, when we put this CSS property to the box, the browser provides this user interactivity, saying, hey, now that you have the ability to this element to resize that. And when you resize this element, you are effectively triggering is reflow, because what happens is that anytime the browser needs to calculate the position or the dimension of these elements, it of course gonna trigger a reflow. It is also overlapping. You have the ability to overlap this, and now you can and now you can get that element anymore because it was overlapping, and then you do this interesting things here. You can even overlapping then to more than that, but again, it's overlapping is on that. This is quite interesting because the browser is continuously putting that, because this element is on the top. You have to be careful with it. Exactly, and the dimension is calculated based on that. In the case of flex, the dimension is calculated exactly. The height of this is calculated based on the models, based on the highest elements here. So the resize provide you that. God damn it. So what you can do is that not only initialize the resizer, okay, and they append that elements to there. All right, and then append those elements to there. We are using this type model. This is quite interesting. Type model in a script. This is a way to make these JavaScript models compatible, right? To isolate for code isolation, very much like that. exactly from code isolation. Because back in the old days, as a way to make this set of functionality or variables not global, but actually is relevant to this, or make this a script only in its own scope, you have to rely on things like immediately invoke function expression and that kind of thing. To demonstrate uses of model, we create a simple set of examples. Okay, exactly. It's a mechanism for splitting JavaScript programming into separate models. But interesting with the resize. Okay, that's lovely, bro. Okay, so the thing here is that not only that we're going to create the Resize Observer, okay, but also get that element, all right. Yeah, but also get that element. So by querying that element by ID, all right, and then attach this mutation, this Resize Observer to each one of those elements, and therefore when we are listening to a particular property here change, in this case, let's say the content is less than 13. We want to actually look at the resize here. What are the properties of this, of the Resize Observer? We say disconnect, observer and observer. The Resize Observer text HTML, font size. That's quite interesting. You set query selector all of these elements, so in this case not. Resize Observer objects, that's right, where you're gonna pass is a callback. That this callback here is made of Resize Observer entry, where they're gonna tell you this border box size, so it keep track. Okay, okay, content rect object containing the new size of the observer element when the callback is run. Know that this is a legacy property that is retained in the spec for backward compatibility reasons only. And the target. Okay. Okay. So we can now is exactly content box size. And the content box size has now the block size, the length of the observer element content box in the block dimension. For boxes with horizontal writing mode, this is a vertical dimension, and height, inline size. An example of this is that, hey, is this entries that we are detecting here when we are reciting this element, when we keep tracking this, when we keep tracking is the element content border or any bounding any bounding element is any bounding SVG element. All right. Okay, makes sense. If entry the content box size is this, if entry the content box size is 0. Okay. The standard makes content size an array, which is quite interesting. But older version of Firefox treat it as a single item. Okay, now we're talking about is the specification here, the content box size. Content rect. and the content box size. Because that we're gonna measure is that content box size. It is quite interesting because it gives you that. So in browsers like Firefox here, let's gonna see what it's doing here. So here we're gonna is get the container, right? Which is they're gonna tell. I want to tell JavaScript, hey, please, I want to get a element by ID because I want to get the starting point, which is the container. All right. The question is that get element by ID is using the CSS query selector. So get element by ID is using the query selector here. Yep, exactly. No, it's by ID. All right, which means is that is this one container get element by ID. So we're gonna get an element for that. It's pretty self-descriptive. Okay, and that element I want you to store on this variable. In this case, in this const, that are not going to be reassigned. I don't want to the value here be reassigned. I want to have this in memory. And then, what I want to do, okay, is to define now the observer. In this case, is the Resize Observer, okay, where you only get is a callback here. What you only get is the callback, right? That's the only thing that you get, that the callback, okay, where now this callback here you are passing, this is a high order function, which means that this object now receives this set of instructions or this callback to do something, to execute that internally when something happened. In this case, we're going to receive is the entry and the observer. Okay, the entries represent is that how many times this is getting triggered. An array of Resize Observer entry that can be used to access the new dimensions of each new element, and the observer is a reference to the Resize Observer itself. So it will definitely be accessible from inside the callback. Okay, so you can access is the observer itself. Is the observer itself, or is a reference of the Resize Observer. Okay. As a way to then, once that happens, you want to disconnect or unobserve that. Okay. Run something and then release that. So we got the entries, which represent is how many times this are getting triggered. Is that how you can have is the object that can be used to access the new dimensions of the elements. Is that how many times these elements are how many times the elements dimensions are changing. So there's a way to actually console log that and only check that, right? And then you say I want you now to assign or to store this reference here on the observer variable, and then you say, hey, I want to now actually is attach the elements to that. In this case, because I want to attach now is this observer, this object that that list that can look at each one of those elements. So I want to subscribe to each one of those elements. One way to do this by using is the for. Using the iterator protocol. Okay, so instead of actually doing that in an imperative way, I just want to actually get that data and do something about it. So that's why we use the for of here. That's why here we say, hey, I want for iterating through the no. Okay. Here we need to do is this. I want now to. So now that I have this entry point, then I want to iterate. Then I want to get all of these elements, which is these elements, right? I want to get all of these elements, and therefore attach the observer to that. How can we do that? Glad you asked. Because we already have this entry point, we can say is, hey, I want you to query selector. Okay. I want you query selector all of these elements. All right. Query selector. Query selector all of these elements. All right. That whose CSS selector is now a box. All right, so it will give me now an array of nodes. Okay, that this array of nodes, I want now is to attach them to. I want to store them into the boxes. All right, boxes elements, boxes nodes. Okay, because after all, that's exactly what query selector is doing. So query selector all, right? That's what query selector all is doing. It's giving you a node list. Okay. Exactly, it's giving you a node list. All right. That's a way to make this. So you say boxes, box node list. Okay. So now we can actually iterate through this list of elements. All right. This interface was an attempt to create a modifiable list, and only continues to be supported to not break the code that is already using that. Model API represent list structure using type based on JavaScript arrays, thus making many array methods available at the same time, imposing additional semantics. Okay, so node list object a collection of nodes, usually returning by properties such as child nodes and methods such as query selector all. This interface was an attempt to create that, thus making many array methods available at the same time, imposing additional semantic for their use. So, live node list, static node list. Okay, which is what we want. I don't want live node, not at all. I want is now static node list, which is a copy of that. Exactly, when any change in the DOM does not affect the content of the collection. Therefore, get a copy of it. It's good to keep this distinction in mind when you choose how to iterate over the items in the node list, and whether you should catch the list dot length, right? So because it is a static, okay, it means that it's a copy that I'm getting from. Now we can iterate through all of these elements, okay, and say, hey, I want to actually is box node list entries, Okay, so this is now the interface that tells, hey, I want you to return is an iterator. In other words, anytime that we are calling this function, or anytime that I want to access to each one of those elements, using the for of loop, okay, I want you to now is give me the value. I don't know how you do that. Do that in the most fastest way possible, but I want to get that. And I want to get that into an tuple like. Because this is now an array, all right? Like it is, because now this is an array. I just want us to actually see what we're getting here as this entry, right? Box node list dot entry for entry of this. There you go. Oh, what? And there you go. So I want you just now is say, hey, I want to is know what is the entries here. All right. Yes, and console log that. So I'm not going to right now is appending each one of those elements. I just want to know is what is this entry elements means here. I'm assuming that this is now a node list, right? The value are nodes okay, the values are node objects. Interesting. So let's get into this. Let's go to run this. And look at the output here. Output or terminal. Output. Terminal. We're gonna look at the terminal. No. Can I look at the terminal here? Can I look at the terminal here? Output problems? No. That's beautiful. What about from the server or the terminal? Exactly. No. Window. The French toast. Window. Terminal. Desk. Server. Go Sandbox Live. Prettier GitHub. What the French toast is this? So what if I want to actually is ebook terminal or yes, like what the French toast is this one? Box node list. Perplexity. How can I see console log in code sandbox from an index.html file with JavaScript code? Be very descriptive. Open the preview console after running your sandbox. Yeah, but okay, it's because no, it doesn't allow me. Yeah, okay, cool. No problem. Check output after running your sandbox. Yeah, it's like you should be able to render this. Yeah, it's quite interesting. What about output? What about I say, hey, hey, run GS model, right? And then you run this change. What in the F? You change to C, and you run this. You're able to see that, but now here, okay. What the French toast, right? Window. Task. Server. No, but it's not the server. Log warning. Log level churn. Warning. Damn, son. Okay. I don't wanna spend too much time here to see if this thing works or not. Share terminal. Create terminal. Resize API. You want to say, hey, npm run def. Okay. Npm star. Okay. Npm star. Exactly. All right. Good. The port is already being used. Makes sense. But I'm not able to see those chains here, the console log, because this is from the server. Makes sense. But what if I want to check is the yeah, the HTML language server. No, but what, man? The window. And for some reason, if I rerun this, right? Oh my god. Oh, my French toast guy, bro. Can I run these things here? Can you provide me that kind of sandboxes? Because honestly, you're not helpful. You're definitely not helpful, bro. Get element by this, not defined. On the container. What? How is that? Get element by this not defined. Get element by the. What? Get element by the. Oh, it's because this is a method from the. Oh my bad. I think that this is a global object, and that's not, and that's not, and that's not. This comes from the document, the DOM API. Okay, you know, we're filling the gaps here. We're filling the gaps here as it is a document, get element by ID, and now it's supposed to actually is run the output properly, right? So the window, man, and these things died. These things die. You die, bro. Anyway, as you wish. Okay. Exactly, it's that document. This global object that is exposed to JavaScript, and there you got it. Okay. You need to use the new keyword as a way to create this function constructor. All right, when you run this, query selector is not defined because it's on the document. That's right. And there you got it, right? Okay, we got all of these 4 elements. Interesting, exactly. So now it's working as expected. So this has not only is the ID, okay, but also the HTML div elements. Interesting. Okay. Okay, so slowly makes sense. So let me actually fix these kind of things, like document here, and that'll be all, right? So when we reload this, the feedback loop here is quite slow, very, very slow. And then you got it, right? Okay, so because we want is to actually is, so it is safe to assume that we're gonna get is the index as well as the HTML element, right? And then we say, hey, I want to know the index and the HTML elements. Missing in a structuring. That's right. I don't know what was that. And there you got it. Okay. So the index and this object, which means is that it means that this elements here, right, on the node list, all right, we need to actually get into these elements. Returns an iterator. It's a key value pair. In this case, the keys are integers starting from 0 and values are nodes. And values are nodes. Don't use for in to enumerate the list the items here. Uses this. So here we are receiving is now the elements, by the way. This node list. Okay. That this node list is returning now is nodes. Exactly. It's returning now nodes here. Makes sense. It's returning now nodes here. Okay. It's returning now nodes here. Where each one of those nodes we want to actually is for each one of those nodes, okay, we can say is here like the inks and the HTML here, right? Because we're not going to use this, we can say this. An HTML element here, but in this case is a node. My bad, it's a node. That's right, it's a node. Where this node is this box that we want is to now, okay, to each one of those elements attach that, you know. Which means is that we need to actually use a new keyword here as a way to make that works as expected. All right. Which means is that here I would like to now attach that observer to that. Which means is that observer dot observe to this node elements here, right? To this particular node, which is a node. The question is that this observer node accept is an SVG element here. You gotta stay there. Is this observer accept now is the Resize Observer. Is this accept now? Oh, exactly. Initiate the observing of a specified element. So it means that because we're gonna get is nodes element, and nodes elements are not elements. Well, actually, we're getting is HTML elements. Is returning is a list of this, right? So node list. Okay. So we're getting is all of this. So for each one of those elements here, which is now the node list, objects are a collection. Notice objects are a collection of nodes, usually returning by properties such as node child nodes. Okay, and message such as query selector all. What we're gonna get is now a non-life value containing one element. Okay, so we are getting is now an elements here, which is what we want, and this is exactly what we expected to be as the input, which means is that we're gonna get is now the element here. Okay, or in other words, is the HTML element. So this is what this is returning from us. And now we want to observe to do that. So that's quite interesting, because once we did this, all right, which of course doing that, any time, you know, it's actually looking at that, actually triggering is that properly. But again, it's for each one of these elements. For each one of these elements. Interesting. So as a way to now know what elements you are actually triggering, right? Which is HTML element here. No, just simple HTML, right? I just want to have access to the content, but because it's part of the node, okay, this node-based class here is the node name, node type, node value. I just want to have access to the content of that, which is text content, exactly. Where here we can say, hey, provide is the text context, right? So run this. Okay, argument 1 is not an object. Oh, of course, my bad, because it's not here. It's in fact is okay. Yeah, it's in fact doing is this entry for each of these elements, which of course they are effectively are element, okay, or one of these entry, where now these entries here we can actually see what this entries is all about, which is part of the Resize Observer entry. And this Resize Observer entry is now this object that will contain is this, the target, okay, where you can say, hey, this is the target that text content, all right, and that's how you can now interact and have access to each one of those elements in that specific node, right? So when we're triggering this, we say, hey, we're triggering this only A. Only A is interesting. We're triggering is A and B. Okay, we're triggering is A and B because both of them are changed. That. Okay. Only B, only B, and in A, only A, right? Exactly. So that makes a lot of sense. So this is a way to make sure that we actually are triggering is this, which is good, which is good. And then here is triggering is only C, but sometimes it's D, which to me is quite interesting. D or C, exactly. So now that we can finally is given this, so now that we were defining this starting point, get this using the document get element by ID, and then query the elements inside of this as a way to get them as a node list by following this class attribute, the CSS selectors. And then using now the iterator pattern that allows to iterate through any collections of elements, regardless it is implementations, okay? And on each one of those elements, we're going to now attach is an observer here, where this observer is when we're going to define is the logic, which in our case we want is to change now we want us to change now is we want us to change now the dimension of this. So we want to check now that content, all right, which after all we can have access to the node and also the HTML elements. So the node doesn't have that property, is the HTML element that has that property. The element here that have that property, the property of the property of width, okay, because we want us to check now is the width of that. Do you have that? Okay. So must be is the HTML element, all right, that must have the width of this, or at least the CSS element where we can have access to that. The style, exactly, the style here is a read-only style property on the HTML here. Exactly. Okay, exactly. So when we are reading is this property on the HTML element, which means that when we are now reading is the style, and of course we're gonna give us this object, the style dot width, style dot how can we access to that style dot width, right? Okay, style dot width, style dot width, can we have access to that? Width, all right, can we have access to that? The style, the read-only style property of the HTML returns an inline style of the element in the form of CSS style declaration. Okay, in the forms of CSS style declaration, which is the CSS text, CSS float. Okay, so get property value, get property value here, margin, exactly, you can say is this, So style dot get property value here of width. All right, get property value here. No, get property value here, and you define as a property value here. No, okay. Well, how can I read that? So this is not the way. Okay, if this is not the way, how can I read that? That's a good question. How can I read the property of that? How can I have access to that class? This is on the style. Okay. How from this can I have access to that area? Child element, class name. Oh, class name is another one. Okay, class name here, but I don't want to check the class name. In fact, I just want to check is the style here. In that HTML local bar, I want to check now is the element here, last element child. No, but the inner HTML is another thing. Okay, from this element, so what are the methods that I can have access to? Append, get element, get attribute. Can I get now the class here? Get element by class name, but no, but this is elements. Interesting. Set attributes, not at all. I'm not interested into that. What about the HTML element here? Attach block instant methods and the event. Okay, now inherit from the elements in node. What about the node? No, but this is from the DOM operations. Exactly. And I need is to access to the HTML element here. Attribute style map. Okay. Attribute style map. All right. Attribute style map, which contains an object. All right. Attribute style map. All right. Exactly, of an HTML interface returning a live. Oh, I don't want to touch that attribute style map. Object that contains a list of style property of the elements are defined in the element inline style, or assigned using the style property of the HTML element. Exactly, element style width. But this is therefore to add a specific style to this. But what if I want to read this that? Because this is the element, all right. And therefore I want to, well, get access to that. All right. Element style background color. You say element style width. I don't know why I can't get access to it with. CSS2 property. This is quite interesting. Because I want to get access to that element, okay, through the targets. And this target is the HTML div element, okay, HTML div element, which is part of that. Inherit related pages, HTML element. In my particular case, I want to have access to this style here. on style. That's to me is quite interesting because I'm trying to get access to style through this dot style. Okay, and then through dot style I want to global attribute containing CSS style declarations. The style, oh my god, the style HTML style, yes. CSS style declaration. What if I want to access to the textual representation of the declaration block? If and only if exposed via HTML style, select this attribute, change this inline style. If you want to text representation of a computer declaration, you can get this as JSON stringify. Okay, but okay. CSX text, and then he say, yeah, your returning is a CSS text. It doesn't have anything. What the French stuff is this, bro? It's quite interesting that I can't have access to that. At least not for what I think of this from the Resize Observer that's contained is the target. Exactly, border radius and width. Oh, contact box size. Oh, here we go. Entry content box size. Oh, here we go. Okay. Content box size. Content rect width. Content rect or content box size? Oh, of course, because I miss. Okay. Okay. So yeah, let's
here,
go to the example.
Then
here.
we need the box. So we're gonna use
border box size. In this case, is border box size. Exactly. This border box size is containing is that. So because this contains is border size, you need to check if that actually is returning that, because it's this. Of course, we're gonna complain about that. Border box size. All right. And this border box size exists because it's returning this. Border box size will contain block size and inline. Exactly, block size and block size. That's quite interesting. Well, of course, initially none. Box size here. Border box size exists.
border box size. And we know that the border box size is the array of a single element.
Border box size now is this. Border box size is now this. We're now going, okay, it's because border box size is that. That's quite interesting. Then we can have access to the block size. Exactly. So here we are getting access to the block size. Okay. Exactly. The other is that, well, for each one of the entries that we're getting, we're gonna get the entry here, which is now a box here, like that. So we're gonna get is the target element. So get the target element here as the entry dot target, as well as the box. All right. To say, hey, target dot border box size, which is a property from this, which is a border from this. Okay, we want to know is the dimension here. So if the border, or is the box size, block size, which is a property that it exposed from the Resize Observer entry, block size is less than 150. Okay, we want is to transform this. Okay, we want to transform this. We want to transform now the target. Okay, that particular element to the dimensions. Okay, of the border radius. Oh, exactly. Is that border radius? Is that border radius? Target box size is undefined. Border box size, because this is something that comes from the Resize Observer here of the block size. So hey, is this target element and contains now the border size? No, but it's from the entries, exactly, not the target. It's from the entry. Exactly. Now I want you to is keep track of this, right? Which means like I want to now is do something like this. So show the block size, right? Block size only that. Block size only that. When you run this, I don't want to actually show all the time this element. All right. I just want to show is that as it is, right? So what I can do here is to say, hey, not only that, I would like to run, which is the Resize Observer, but is now the target, which is, hey, I want to now that particular element, okay, that particular element, which is an HTML element, here I want you to know is style. Okay, the border radius. So I want to now actually change that of the border radius. Say the border radius. So the border radius here. Yeah, the border radius. Exactly, the border radius. No, but this is the target. Exactly. For example, the implementing this using border radius, which is border radius. Exactly, then you change that to what we need to. Just in our case, I'm going to change now the border radius. The border radius to 100%, exactly. To 100%. All right. You say when that happens, it's going to change to that. So otherwise, right? Otherwise, so we can store that by saying is the border radius value, border radius, to say, hey, target dot style. Oh, but no, if we change that, as we have, we can say that is to set to whatever it was, right? To whatever it was, which is what was before, and what was before is this particular style that we have here. Border to pixel here, like that, right? So target.style.border radius of this particular value. Well, actually it's border. You're gonna use border here for doing that. And then when it comes back, so border radius here is to 0. So this is how you can now partially is doing that. So to override this behavior, and that is applying this value here. So the border radius, it won't be able to. Okay, it's because this is the logic here. So if this is greater than that, less or equal than, you're gonna apply that. If it's not, you're gonna apply now the border radius to the element, which is 0, 0, inherit that property as is, which is quite interesting. It's not able to apply that. So because it's not able to apply that, that's quite interesting. Of the box, we say, hey, border radius. So border radius is 0, right? So border radius is 0. Return to whatever value it is. But I don't know why this doesn't work. It's like, okay, no problem. Well, that's what it is. One of the things that I don't like about this is that we are mutating is the state of that. But in any case, but yeah, we actually did it for these elements and for this another one, and for this another one, which is a great thing. And this is one of the awesome and powerful thing of this, is that it allows us to do this. Holy moly, bro. And that's pretty much it.
Elements, so we select the box, and now we need to check that the box block size is less than 150, and we so now our observer is created. Let's query the box elements. We should see that now where you have multiple windows, so you can
because we're not modifying is that 2 pixels. Okay, exactly. So this is a very interesting applications of this. So you can rerun this, right? And now you're able to see is this silly example of the Resize Observer API.
We should see that now it works. So we have our 4 rectangles that resize becomes a circle and rectangular again. So the main idea of the Resize Observer is very useful for the application where you have multiple windows. So for instance, it can be trading app, and a very common use case, you have some charts on your trading app, and you need to update the toolbar, how the toolbar looks like for each chart. So you can set up one observer to track all the charts on the page, and then the toolbar will be updated with the single observer. And let's quickly overview the solution. So we basically created the observer, look through the all entries, and check if the size less than 150 on the target element. We update the styles and then unset them if if it's not the case. Then we create all the boxes and register the observer.
So it changes once you hit that 150, but like as you keep moving it, if you're staying under that 150, is it still like reapplying those styles over and over again? Basically?
Yeah, so the callback is fired, so you still need to still need to probably debounce your callback to make sure that it's not firing too often, but it will be
exactly, because it's firing is a lot of the time. You probably need to debounce your callback here.
much more performant than your Resize event.
For sure.
So Observer API is a very fast way.
Again, basically.
Yeah, so the callback is fired, so you still need to still need to probably debounce your callback to make sure that
which is in this case the bounds the callback here. Performance optimization, the bounds the callback. To do performance optimizations, the bound the callback here.
It's not firing too often, but it will be much more performant than your resize event.
For sure.
So Observer API is a very fast way, is a very performant way to for implementing complex patterns. So if you're in your application, you have a legacy way how you implement such things. For instance, with intersection, you set up a set interval, or with a resize event, you're trying to check the element size. Then it's better to replace with Observer API. Observer API already have 98% support of the clients. So for the rest 2% of the clients, you still can do the polyfill. That will not be as performant, but for at least for 98% of the client, you will deliver a good app experience.
Do the inline size and box size values change when text is being written?
At least for 98% of the client,
exactly.
you will deliver a good app experience.
Do the inline size and box size values change when text is being written vertically, like in Japanese? Or can you assume that inline is always horizontal and block is always
Yeah,
vertical?
this changes with the settings, LTR or RTL, and from if you render things from top to bottom, but instead you may have you can change the perspective how you render things. Then the inline size will track the height instead, and inline, and the other property will track the width. So you need to check the CSS spec exactly when it happens.
One more question. Does mutation observer with subtree true at poor performance if we have 1,000?
The CSS spec exactly when it happens.
One more question. Does mutation observer with subtree true at poor performance if we have 1,000 child nodes?
So it might be an issue on the low hardware, but because the mutation observer is actually implemented on a native level, then the performance should be still good, but it's always better to provide the specific configuration, what you track. Make sure that you don't track too many things. If you want to track just the character data across the whole tree, then make sure you filter out the attributes changes and the DOM nodes changes. So this way you can optimize the performance. But of course, if you're trying to track 10,000 elements, then even on a native level, you may end up having the issues. The way how you can optimize tracking, for instance, how the markdown editors do that. So when you select specific line, so instead of tracking the full document child tree, you set up the observer dynamically on this specific line selected by the user, and when then the user types, you track only a single line of data, and that's how you can optimize the mutation observer.
In this case, as a way to know, instead of actually tracking as much as element possible, to reduce the amount of element possible to be tracked of, and so it needs to actually require a more neat talk. Okay. A nip and tuck. Exactly. A nip tuck, plastic surgery. So a nip tuck or a let's say nip tuck or chirurgical procedures, exactly, because here you need to be here you need to be chirurgical when you're going to now decide which elements you want to actually inspect. So yes, on low power hardwares, it may have a negative impact, especially if you want to render huge of elements. So if you're not careful enough, you might end up having, of course, those performance issue. However, because this is something that is natively, it is something that it's going to do. It's gonna bring the performance as it's gonna make your application as much performing as hardware and software capable of. So what is the metric here? So rendering 1000 elements on low hardware powered device might not be a good idea, even though that, especially if you need to use polyfills, definitely not. But if you rely on that those end users device actually can have access to the mutation observer, and therefore you are now being chirurgical when you are going to append, when you're going to listen, observe the mutations of those elements. So 1000 elements might be a good, you're gonna get a good performance overall. That'll be all for this video. Take care. Bye bye. Jesus.